Now we're going to look at how to calculate probability for non-disjoint events. So two events are non-disjoint if they can occur at the same time. Can occur at the same time. So looking at our picture, we have our sample space containing all of the outcomes of a probability experiment. And within these outcomes, we have the event A, which is this entire circle here. And then we have our event B, which is this entire circle here. And notice these two circles overlap. So there are outcomes in A and B that are common to both circles. So that overlap of potential outcomes make the events non-disjoint. So if we think about the example from before where where the sample space was us going to an animal shelter, and A was the probability that we adopt a cat, but now B is the probability that we adopt a gray pet. There is overlap here. There are cats that are not gray, but there are also cats that are gray. And then there are pets that are not, other pets that are not cat, but are gray. But then there are also pets that are gray that are not cats. So we have options that are not in A, that are in A and B, and options that are just in B. I really hope that made sense. So to find the probability of A or B, we're still looking at A or B in this case. But now we're looking at what happens when A and B are non-disjoint. So that formula, probability of A or B, is found by looking at the probability of A plus the probability of B minus the probability that A and B occur. So we look at the two things individually, but when we look at the two things individually, we end up double counting that overlap that happens. We count it as part of A and then we count it as part of B. So we have to subtract off one of those double countings. So let's look at an example of this. We're going to use this spinner to answer the questions below. So we have a spinner with numbers and different shades of white and grays. So find the probability of landing on an even number or a light gray space. So we're looking for the even numbers or the light gray spaces. So the probability of an even or light gray. So I want to find the probability of an even. I'm going to add the probability of the light gray, and then I'm going to subtract the probability of the even and light gray. So the probability of an even space, I have 1, 2, 3, 4 out of 8, plus the probability of a light gray space, 1, 2, 3, 4 out of 8, minus the overlap. So the number of spaces that were circled twice. So that's this one and this one. So 2 out of 8. So 4 plus 4 minus 2 is 6. and the denominator stays the same, 6 out of 8, and this is 0.75. If I didn't subtract off the overlap, I would have had 4 out of 8 plus 4 out of 8, which would have been 8 out of 8, which would have indicated that I had circled every single space. But if we look at my current drawing, I have not circled every space. And that's because I circled 2 of the spaces twice. So I need to subtract off the fact that I've double counted the 6 and the 8. So I'm going to erase my drawing and I'm going to do another one. So find the probability of landing on a multiple of 4 or a white space. So multiple of 4 or a white space. So multiples of 4 are, if I multiply 4 by another number, what is the result? So that would be 4 and 8. So there are 2 multiples of 4 plus the white spaces. There are 2 white spaces minus, how many of these spaces did I circle twice? 1. So 2 plus 2 is 4, minus 1 is 3. 3 divided by 8 is 0.375. And that is how we find probability of disjoint events. Nope, probability of non-disjoint events.